Hello everyone, welcome to the HashiTalk build. I'm going to share with you about the documentation journey for AWS Cloud Control Provider. We have a lot to cover and I'm sure you have a lot of questions, so let's get started. My name is Welly Siauw. I'm the Principal Partner Solution Architect here at AWS. Today I will be joining with my colleagues and friends, Dr. Rahul Gaikwad. He's a lead consultant at AWS. I'll start by setting some stage and then Rahul will join us later for the deep dive demo. Now, let's imagine this. You read the AWS news announcements for a new service, and that's happened on Thursday morning. And then you found that the resource or the data source is available in the Terraform region that's available on Tuesday afternoon. Then no more waiting for someone to open GitHub issues, thumbs ups, or maybe making a pull request. At AWS, I had an opportunity to be part of various AWS service team launches, and I know exactly the level of effort made by various teams, including service team, the providers me, and also the Terraform team itself. And for some of you, you have contributed to the AWS provider, so you know exactly what I'm talking about in here. And we make a lot of progress on this front, and I'm very excited to share some of the new approach and progress we made today. So for that, first of all, I want to introduce you to AWS Cloud Control Provider, or we call it AWSCC. It's a fully auto-generated Terraform provider. It provides you access to provision all of the hundreds of AWS resources that is currently supported, and all using single consistent API. The AWSCC automatically syncs with the registry, Cloud Formation Registry, and it uses the Cloud Control API to generate that resources and the schema and handlers. That means automatically you get access to those resources typically within days, sometimes within hours. So are we there yet? Is this the promised land? Now, the fully automated workflow in AWSCC begs the questions. Are there something else for us as part of the open source contributor to contribute? And the spoiler alert is yes, we are not there yet. We have plenty of other innovations to work on. So stick around and we're gonna learn more. But first, it would be a big mistake not to recognize the big key role played by all of the Terraform contributors. Thank you to you all. The fact that we have such a healthy and engaging community is a big asset that we all play a key role on. AWS providers is on track to hit 2 billion downloads, and that popularity is testament to all of the effort made by the contributors and also by the community. So switching the gear back to AWSCC, maybe the first questions that come up in your mind is, what is AWSCC? Why I never heard about it? What can I do? So let's take a step back in time and rewind a bit. It all started with motivations. We all want to deliver new business value. We want to tackle hard problems, and for that, you need to unlock access to innovations. With hundreds of AWS services, that momentum is just keep rolling faster and bigger. Take a step back. More than a decade ago, AWS launched 80 significant features on that year. If we fast forward to 2021, after a decade, that number is actually 3,000 features and more. Last year is 2022. We had 3,352 significant features that was launched. So we asked ourselves here at AWS, how can we help our customer gain access to these features? And we know that they want it fast, they want it now. And the signal is very clear. Our customers, we want to use Terraform to provision the infrastructures. So let's take a sample of this simple SEL configurations. Now here I have an IAM role, VPC, and also an S3 bucket. In AWS, you often hear us about 2 pizza team. We operate lean and fast. So that means each of these services has its own API endpoint. has its own create, read, update, delete, and list operation, or we call cradle, create, read, delete. And then each of those APIs also has its own schema, handlers, and also the error code. So take example of that previous ACL configurations. The binary of Terraform handle the parsing, synthesizing providers, and validate the ACLs. Then the provider act as a plugin that interact with the external API. In this case, are the AWS services. And because they are each in terms of the implementations, that provider, AWS provider, act as a translation layer between the Terraform and the services. So when a new feature services is launched, then we repeat the process, the API spec, open a GitHub issues, create a pull request, running a test, review the request, and then merge and approve, and etc. You're all very familiar with this. Now, you can imagine this can take days, weeks, and sometimes months, especially for new services. Now imagine we don't have to do that because imagine you don't need to use, well, imagine that the Terraform provider don't have to interact with each of individual services. Now imagine it can interact with just single API that consistent with the consistent cradle essentially. And this is what led the development to the AWS Cloud Control API. And it acts as that consistent cradle API that's supported by the other AWS services. And at the same time, HashiCorp teams also developed the AWS Cloud Control Provider, or the Terraform provider for it. So great stuff, sounds great, very promising. But again, what is Cloud Control API again? You might ask. Okay, next couple slides, I'll try to explain what is Cloud Control API without saying Cloud Control API. So first, imagine you have this, you just need to remember that create, get, update, delete, and list. And because there's only 5, I don't have to map the AWS SDK for each of those services because all services use the same 5 command in here. Theoretically, I can get consistent response and also error handling from this one API. So that's the first design principle. Second, imagine you have consistent schema for that resource definition that you try to hit through that 5 API calls. Basically, that's the standard specification of how you develop resource in AWS, like properties of the resources, the data types, for example, which parameters are required, the identifiers, and etc. In theory, if I have consistent schema structures, then I can programmatically scan that schema to map all of my resource attributes. So also means that I don't have to inspect the resources for each of the AWS services individually to make sense of their schema. I can just go to one location. So then that leads us to the third component. And that is the place to find the schema at the registry to publish the schema to the external party. So if you try to put that 3 design components in practice, we start with the registry. This is the CloudFormation registry, where each services, when they onboarded a new feature or new services, they publish the schema into this registry. When they develop new services, it's mandatory for them to include that schema prior to the service GA or the service launch. And then we download this registry. There are multiple endpoints provided by the registry to download the schema file. And of course, we do this programmatically. But in case you're curious, just Google CloudFormation registry schema downloads, and you can find a link to actually inspect the file. Now then, here's the cool part. The AWSCC provider team is done by HashiCorp team in here. They have a cool code generation tool. It runs weekly. It downloads the schema file, and then it doing the diff to find what's the new resources. And when you find it, it read that resource provider definition schema to understand what are the attributes of the resources. Again, remember we have only 5 API call to remember: create resources, define the schema, and etc. So As you can imagine, some resources can be complex, right? It could have nested attributes, lists, maps, map of strings, map of lists, min-max values, and etc. So this code generator takes that into all accounts, and then it generates the provider handler for the resources. It has the data source as well. It provides acceptance tests and also the documentation. So from here on, the build process complete, new release is made available. You go and update your provider, AWSCC provider versions, and then you can start using that resources in your SEL configurations. So very, very cool. There's a ton of work done by both HashiCorp and also AWS to make this happen. This entire process is way more complex than what I can explain in here in just couple of pictures. In fact, it may warrant its own HashiTalk discussions. But for now, let's just refocus ourselves on the last pieces in here, which is the documentation. So I explained to you what is Cloud Control API without saying Cloud Control API. And also earlier I mentioned that the AWSCC code generator also generates the documentation for you that you typically saw in the Terraform registry. So if that's the case, then why we are here today in this HashiTalk sessions, right? The documentation has already been generated as well. But let's take a look. First, I want to take you to the familiar registry documentation for AWS standard provider. Now, when a contributor wrote the resource provider, they add practical example how to use the resources. Over time, these examples are getting better and better with complete example that you can almost copy paste to your configuration. And on top of that, the argument or labels description is included, often with great practical example that provide pro tips, call out for edge cases, rough edges, and best practice as well. And now if you kind of bring it to another example, very familiar page, but a little bit barren. And this is the same resource documentation, but this is in the AWSCC provider documentation in the Terraform registry. Yeah, so it doesn't take train eye in here to notice. We don't have practical example in here. And for you, maybe you're pro users, you don't need example, you can just kind of configure it. But for many practitioners, we often hear this is the first frictions in terms of using AWSCC provider and arguably any provider. So we are human. We are trained to mimic what we can learn from the word. And in the absence of example to mimic, then the friction essentially filling the gap. And you also notice the argument description is quite bare bone. I took a very extreme example in here, but just to illustrate the problem. But this is consistently a problem that we are facing in this particular phase, particular topic. So why is that? It's because the documentation is rendered from the resource provider schema in the AWSCC repository, which in turn actually come from the same resource in the CloudFormation registry. And this is what that resource schema looks like in the CloudFormation registry. Skip the other part, just kind of focus on the pieces that are highlighted here, and you notice that there is no descriptions about these properties. And that summarizes the problem statement. First, we need a practical example. We also need to enrich the property descriptions. We know that we need to improve, and there's only better result from here on. And look at this example in here. This is for the OM link resource. By the time we finish with this HashiTalk, I encourage you to go to Terraform registry, look for it, and see what's the result on the AWSCC. So we are making progress. So switching gear, a quick deep dive. I want to introduce you to the Terraform plugin docs, also called the TF plugin docs. If you're a provider developer, you probably are familiar with this. And maybe for you, AWS provider contributor, this may be a little bit new. The Terraform plugins is capable of this Terraform plugin docs capable of generating documentation in the Markdown format. It takes SQL file, say this example TF, and then it render it with the Markdown example templates, and along with that, it also generates other resource properties. It then export this schema information from the provider. You can run that by using this Terraform provider schema command. And the Terraform plugin does also generate both of the resource and the data source documentations. My colleague Rahul will demonstrate how this works later, but just a very quick sneak peek. Here's the just regular Terraform example file that I showed you earlier. And then this is the Markdown templates. Rahul will go more deeper into these Markdown templates and how they use. And then finally, this is the Markdown outputs, which then been rendered in the Terraform registry. All right, so that's just a quick sneak peek. In the next session, we'll dive deeper. Rahul, please take it away.
Wow, that was amazing. Thanks, Welly, for sharing your valuable insights. Let me take the baton for a moment and demonstrate practically on what you just said. All right, it's a show time. My name is Dr. Rahul Gaikwad. I am a lead DevOps consultant at AWS. Today, I would like to demonstrate how you can contribute to Terraform AWSCC provider documentation. Before I start on demo, I would like to share one of the customer use case. In 2022, I was working on one of the customer engagement at AWS, where customer wanted to deploy AWS Fault Injection Simulator Service, that is FIS, using Terraform as infrastructure as a code. When I looked for a Terraform AWS provider resource, I could not find any because FIS service was quite new at that time. Then I researched and I got introduced to AWSCC provider where I could explore and deploy FIS using AWSCC without any further waiting on AWS provider. Now, let us switch the gear and deep dive into how each and every one of you can play a vital role in contributing to the AWSCC documentation. I will also explain the contribution steps and give you the opportunities to make you an impact to the HashiCorp and AWS community. Imagine you are an aspiring contributor and ready to conquer the world of Terraform AWSCC provider. But wait, how and where do you start? It's a multi-step process to contribute to the AWSCC provider documentation. Firstly, I will explain 4 steps at a very high level, and then I will deep dive in each step. First thing first, we need to choose our weapons of choice. I will talk more about tools and setting up your dev environment in upcoming slides. Once you set up your playground, identify the available AWS resource to write an AWS example. You may want to deep dive to the AWS resource before you actually develop your own example. There are plenty of options available for you to explore and learn about that resource. Now, suppose you all learn about that AWS resource and understand how it works. Now, here it's your time to get hands-on and build a new AWS example. Alright, at this stage, you have finished your example with your coding and extensive testing. Once you are satisfied with your example, confident in your test, and ready to share your contributions with the community, you can submit your pull request. And that's it. You just impacted a broader community by submitting your great contribution. Now, let us deep dive in all these steps one by one. First, you need to set up your dev environment. You can choose your favorite development environment. My favorite development environment is Amazon Code Catalyst. Someone may ask, why Amazon Code Catalyst? As developers, we know that our core capabilities lies in creating innovative and efficient code that solves business critical problems. Yet, we often find ourselves distracted by the complexities of setting up and maintaining our development environments. One of the key advantages of this setup is that it comes with a pre-installed dependencies, eliminating the need for a manual intervention. Whether you love using Visual Studio Code, PyCharm, IntelliJ, or any other IDE, Amazon Code Catalyst supports all of them. First of all, you wanna pick a resource, you can go to the AWSCC registry, search and browse for any resource that you are interested in. We recommend you to explore the resources and pick any available resource which you feel confident. Once you pick up the resource, I highly recommend you to deep dive in that resource. You can either go through the AWS documentation to understand how that resource works, or you can also check AWS CloudFormation documentation to learn about that resource schema and their attributes. Before you start on AWSCC example, you can also visit the Terraform AWS provider documentation and their examples. You can even demonstrate your creativity by writing a multiple examples, including basic example and advanced examples covering specific use cases. After you learn about the resource, you can build your own test example using Terraform AWS provider. It's important to understand how it works with the Terraform AWS provider. Then it will be easy for you to write an example in AWSCC provider. You should explore the resource and their attributes by running Terraform plan. I encourage you to do extensive testing by running Terraform apply. You will understand how the resource gets provisioned using Terraform AWS provider. Once you understand how AWS resource works with the Terraform provider, now you can deep dive on the Terraform provider AWSCC repo and you can explore that repository. Try to understand that repo structure, go through the README, some existing examples, and earlier PR contributions. There are many directories in here. For now, pay attention to just three. The first one is example/resource directory, templates directory, and the docs directory. Then you need to fork the Terraform provider repo in your own GitHub repo or GitHub org. You should clone your forked repo in your dev environment which you set up in last stage. Once you set up your dev environment, you can clone your repo and you should create a new feature branch. You can follow these naming conventions for creating a branch where D represents the documentation. In this step, you can start writing your example in conventional path. As you have already explored a repo structure, you can easily understand that your example should be stored under the example/resources folder with your resource name. Once you completed your example, you need to create markdown templates where you define some high-level description. The templates provides a couple of useful contexts that you can use out of the box. For example, .name, name of the resource or data source. .type, either resource or data source. Description is a description of resource or the data source. Also, notice in here I get a creative and I put a three examples for different use cases as shown. You need to store your new template in the conventional path. For resource, you need to place under the template/resources/folder. Also, pay attention to the template file name. We encourage you to keep the consistency format. For simple use case, service name hyphen resource name dot md dot tmpl. For multiple example, service name underscore resource name underscore use case slash example dot md dot tmpl. Then you do a linting, making sure you don't make any typos or unintentional errors. Then you do a local test by running a make docs. This is a creating for actual markup documentation from earlier example and markdown templates. Then create a draft pull request with work in progress at the beginning of title so that others can understand that you are still working on it. Once you are ready after extensive testing, you can remove that WIP tag and submit for review. Once you submit it, it will go through the auto check process. If any check fails, you need to troubleshoot, fix, and recommit. Once all checks pass, reviewer will pick up your contribution and provide the feedback. If all look good, reviewer will provide his comments and he may approve your PR. That's it. Next is a call for action. Alright, this is now the end of the presentation. We would like to share a couple of key takeaways for you. If you are interested with what we are working on here, please join us and start contributing. If you are brand new to AWSCC provider and want to learn more, here is the examples that you are looking for. We have so much more to do. Let me share a couple of things in our mind right now. First, we have seen increase of adoption of AWSCC, and with that, we also started to look for the automated solution and fixing it. If you see some issues with AWSCC, don't hesitate to raise the GitHub issue. Second, we are also actively looking for the active contributor. If you have any idea, open a future request in the AWSCC. We want to hear your feedback. Lastly, since Gen AI is a hot topic, perhaps someone from the audience may want to leverage Gen AI for the AWSCC. We'd like to hear your feedback and your experiment as well. Thank you so much for your time. Enjoy the rest of HashiCorp conference. Thank you. Bye.